Hello and welcome back to MaisonUp. Today, we are diving headfirst into the fascinating world of monochrome LCDs. Before we proceed, let's take a moment to demystify these remarkable displays. LCDs work on the fascinating principle of liquid crystals, which have the unique ability to align themselves between two differently polarized layers. This allows them to either let light pass through or block it, thereby creating the visual content you see on the screen. These displays come in various configurations, the most common being the 16:2 model. This model offers 16 characters across 2 rows. For those in need of more display real estate, there's also a 16:4 variant that gives you a 16-character display spread over 4 rows. What makes LCDs particularly compelling is their ease of manufacture and cost-effectiveness. Not only are they relatively cheap to produce in bulk, but they also require minimal current to function. This makes them the go-to choice for battery-operated projects, whether you're working with Arduino, Raspberry Pi, or even just need a display for serial monitoring. Now, let's demystify the pinouts on these displays. A typical LCD display has 16 pins in total, stretching from pin 1 on the far left to pin 16 on the far right. Pin 1 serves as the ground. Pin 2 is for VCC, which is the supply voltage. Pin 3 lets you adjust the screen's brightness. Pins 4 and 5 are dedicated to register select and read-write functions respectively. Pin 6 acts as the enable pin. Pins 7 to 14 are the parallel data input pins. Finally, pins 15 and 16 control the anode and cathode of the backlight LED. Now that we've got a handle on the basics, it's time to dive into some practical experiments. For our first experiment, we'll focus on integrating an LCD display with an Arduino board, specifically an Arduino Nano, without using any I2C adapters. Let's gather the following essential components. Arduino Nano board, the heart of our experiment. LCD display. We will work with most common 16:2 display, 10K potentiometer and 220 ohm resistor. These components will allow you to adjust the display's brightness for optimal viewing. Small breadboard and jumper wires, to make connections easy and organized. Now that we have everything we need, we are set to dive into the hands-on portion of the experiment. Let's wire the LCD display to the Arduino Nano. Connect the 5 volts output from the Arduino Nano to pin 2 on the LCD display. Connect the ground from the Arduino Nano to pin 1 on the LCD display. Attach both ends of the 10K potentiometer to the 5V and GND outputs of the Arduino. Connect the middle pin of the potentiometer to pin 3 on the LCD display for brightness control. Connect Arduino pin 12 to pin 4 on the LCD display. Ground pin 5 on the LCD display. Connect pin 11 on the Arduino to pin 6 on the LCD display. Connect Arduino pins 2, 3, 4, and 5 to LCD pins 14, 13, 12, and 11, respectively. Connect pin 15 on the LCD to 5 volts on the Arduino through a 220 ohm resistor for backlight control. Connect pin 16 on the LCD to ground on the Arduino. And there you have it. With all the hardware connections in place, we're ready to delve into the software portion of this experiment. After successfully connecting the hardware, the next step is to upload code to the Arduino Nano using IDE to bring our LCD display to life. Arduino IDE provides a built-in library called Liquid Crystal that simplifies the process of programming LCDs. Let's get started. In the Arduino IDE, go to File, then Examples, then Liquid Crystal. This folder contains various sample sketches to get you started with LCD displays. Inside the Liquid Crystal folder, locate and open the Hello World example sketch. This is a simple program designed to display a message and a counter on your LCD. At the top of the sketch, you'll find comments that give credit to the author and offer some general wiring instructions. The code defines which Arduino pins are connected to the LCD pins using integer variables. This is where the LCD display gets initialized. The display's column and row size are set here. This is the core part of the code. It sets the cursor position on the LCD and prints the Hello World message along with a running counter that displays seconds elapsed. Once you've reviewed the code, connect your Arduino Nano to your computer via USB. Hit the upload button in the Arduino IDE to compile and upload the sketch to your Arduino. After successfully uploading the code, your LCD should display "Hello World" on the first line, and a running counter of seconds should appear on the second line. You can adjust the display's brightness using the potentiometer to optimize visibility. In this experiment, we'll take things up a notch. Let's build a mini weather station that can display temperature and humidity readings using a DHT22 sensor, while also acts like a desk clock that can fetch time from the internet and display it in our desired format. We will also become familiarized with the I2C adapters, which can be directly soldered on top of the LCD display. These nifty devices simplify communication and significantly reduce the number of wires to just 4 for your project. Let's start with components. We will need a NodeMCU board, an LCD display with a pre-soldered I2C adapter, a temperature and humidity sensor. For this experiment, we'll be using the DHT22. Lastly, you'll need a breadboard with power supply and a few jumper wires to facilitate our connections. Let's connect all the components by following the diagram. Connect the SDA pin from the I2C adapter to D2, and the SCL pin to D1 on the NodeMCU. Next, connect the VCC pin of both the LCD and the DHT22 to the 5 volts output of the power supply, and connect their ground pins to the ground of the power supply. Lastly, common the ground of the LCD with the ground of the power supply. For this experiment, we will be writing a basic code that utilizes the DHT22 sensor to fetch temperature and humidity readings and display them on our I2C display. The code will also connect to an NTP server to fetch the current time and display it on the screen, serving as both a desk clock and a weather station, swapping each mode at 5 seconds interval. It's worth noting that you can use ADHT11 or similar sensors with only minor modifications to the code. Don't forget, you can always download the required sketch and libraries from the link provided in the description. Let's upload the code and see the magic. There you have it. You now proudly own a real-time desk clock and a mini weather station. You have learned to successfully integrate a monochrome LCD with your DIY projects. But this is just the beginning. Stay tuned for more exhilarating experiments and tutorials. Thank you for joining us on this journey. Happy tinkering!